Welcome to the project demonstration of generalized state space average model for multi-phase interleaved buck boost converter. So for the DC loads along with pulse width modulation waveform plotting using MATLAB, and we interface for interfacing we are making use of PL2303 USB to serial converter module. So here the flow is we are going to provide the 230 volts input and from this cable, and that will be stepped down to the 12 volts of AC voltage, and with help of this 4 diodes rectification we are going to convert that AC to the DC, and that will be the pulsating DC. After the pulsating DC, using capacitor we are going to remove the pulses, that will be get the pure DC voltage, and after this 7805 regulator will get the 5 volts. So this 5 volts is main input power supply to our PIC microcontroller, and this 12 volts of DC is main input power supply to our load through this buck and buck boost and boost converter. So these are the three, we are going to interleave them in one project based on the input signal voltage that will be measured by our PIC microcontroller, and the so-called status will be displayed on the LCD screen, and we are going to change the input reference voltage with the help of potentiometer, and based on that we are going to control the pulse width modulation to these 3 MOSFETs, and based on we can control the regulate the output voltage to the loads also. Okay, so let us see the demonstration. So here these 2 transformers are used as inductors because the primary coils and the secondary coils of the transformer is made of copper coil, so that we are going to making use of them as an inductor in our buck and buck boost converter. So, and also in the boost converter there is one inductor here, we can see that there's 100 microhenry, and here the 3 MOSFETs are IRF Z44. And coming to the operation, so whenever we switch on this kit, it will check the input voltage, main input voltage and reference input voltage. We are going to control that by changing the pulse width modulation to this MOSFETs, nothing but on and off duty cycle time. Based on the on, so the inductor will charge and discharge, and when it is off, the same voltage will be given discharged to this capacitor, and the particular capacitor will charge. Based on the on time, the output voltage increase or decrease, so it will be monitored continuously on our laptop screen also. So let us see the demonstration. Before running this project, we need to install the application of PL2303 in our laptop, as we installed it already. So these are the applications we need to install. Okay, so this is a waveform, is a main code of our project, and in this we have already provided the MATLAB and as well as PL2303. After installation process, just connect this to the same USB slot, always better to get the same COM number. So after connecting this USB into a laptop, go to the device manager. So just right click on this PC and go to manage, and there will get the device manager. So in this we can get the port numbers, so you can see these are ports, right? So note on this COM number is COM number 3, note on that, and go to the MATLAB code, so which we have provided. Open that file, so there's a waveform plotting using MATLAB, and in that we need to do only one change. Already we have changed that, no need to change again. So COM 3, right? And after this, just provide the main power supply to our project. Initially we will show you the demonstration here. So right, so there will be a welcome message, and also load will be controlled. So whenever we changing this, we can observe the load is changing. Slightly, right, you can observe that. So this is slightly changing in the load section. Okay, right, you can observe here what are the operations selected here, the boost, and next it's going to be the buck boost. Okay, and next boost only, and buck boost, and next last it's going to be the buck. Right, it will take some time while you changing this. Okay, so just I'm restarting it and run the code directly, MATLAB code. Just open this code, click on this code and do run on this. The code will be run and you'll get the waveform plotting also, right? Now it's getting the waveform plotting. Now it is in full mode. So that's why it is getting continuously constant 5 volts. So now I'm changing this, so you can observe that I'm decreasing. Now you can get the off time also. Right, the off time is started. So now it is in buck boost mode. Right, so slightly I'm still rotating that, and you can see the on time is decreasing, off time is increasing. So you keep on changing that. When it is enter into the boost mode, you can see the on time is very less than the off time. The 0 time is off time and 5 volts is the on time. Right, now you can see that now the on time is very less, and now I'm increasing that. Right, see, I'm keep on increasing the on time now. Okay, right. In this manner we are going to control in the interleaved buck boost converter. Now it is going to the maximum of level. Right, now we will enter the maximum difference voltage in the buck boost mode. Right, thank you.